In today's video, we will consider more applications of Gauss's theorem. In previous video, we have seen electric field due to a uniformly charged sheet, and electric field was coming out to be sigma divided by 2 epsilon naught. In this case, we will consider the same result for different situations. So today topic is electric field due to two positively charged parallel sheets of plate. So here we are going to have two positively charged parallel sheets of plate, and it is asked find the electric field intensity outside this plate, this side, outside this plate, and in a portion that is in between plate first and plate second. So this is positively charged. Electric field intensity because of this positively charged sheet will be in outward direction. So if I will consider because of this sheet, E1 is electric field intensity, so its direction will be in outward direction on both the sides. And because of this side electric field intensity E1 direction will also remain the same. Whether you keep it or you don't keep second sheet, direction of E1 because of this positively charged plate will remain this side, and this is also positively charged plate. So if you will consider direction of electric field intensity because of this plate, then this is in outward direction, this is in outward direction. Also, if I will consider its effect this side also it will be in outward direction. So in every region where we have to find the net electric field intensity, we will focus what is the direction of electric field intensity due to first plate and electric field intensity due to second plate. This was about direction, and magnitude formula we already know. E1 will be equal to sigma 1 upon 2 epsilon naught, and E2 magnitude will be equal to sigma 2 upon 2 epsilon naught, where sigma 1 and sigma 2, they are representing the surface charge density of first plate and second plate, and R is representing a unit vector pointing from left side to right side. So when we will consider this region first, here electric field intensity E1 and E2 both are pointing in the same direction, but their direction is opposite to the direction of R cap, because R cap is pointing from left to right, and E1 and E2 in this part they are pointing from right to left. So when I will write E1 using R cap, then formula will be E1 vector will be equal to minus sigma 1 upon 2 epsilon naught R cap. What is the significance of negative sign here? Significance of negative sign is E1 and R cap both are acting in opposite direction. Then what is electric field at this point due to this charge sheet? Due to this charge sheet, this magnitude is independent of R. So E2 will be equal to minus sigma 2 upon 2 epsilon naught R cap. Net electric field intensity will be sum of these two. So when you will add these two, minus R cap upon 2 epsilon naught will come outside, and within bracket we will have sigma 1 plus sigma 2. And if you want to see this result, how this was derived, then I will give the link in prescription also. If we will go for region second, in region second, because of this electric field is in this direction, and because of this sheet electric field is in this direction, both are pointing in opposite direction. So net electric field intensity in second region we will consider their sum. So E1 will be equal to sigma 1 upon 2 epsilon naught R cap. E2 will be equal to minus sigma 2 upon 2 epsilon naught R cap. Here E2 and R cap are in opposite direction. Here E1 and R cap are in same direction. So what will be net field? Net field will be addition of these two. R cap upon 2 epsilon naught will come outside, and inside we are left with sigma 1 minus sigma 2. In region 3, both are pointing in the same direction, and this direction we are going to have same as that of R cap. So what we will have, E1 will be equal to sigma 1 upon 2 epsilon naught R cap, E2 will be equal to sigma 2 upon 2 epsilon naught r cap. When we will add, we will get this result. This was one case. Another case is when one plate is positive and other plate is negative. In that case, what will happen? In this case, first step is we will see what is the direction of electric field intensity in the three regions which are asked. This is first, this is second, and this is third. Each plate is having surface charge density sigma. Here we have negative charge, here we have positive charge. So in this part, electric field intensity because of this plate will be in outward direction, and electric field intensity because of this plate will be in inward direction towards the negative plate. So these both are pointing in opposite direction. If I will consider region second, because of positive it will be in outward direction, because of negative it will be in inward direction. Both are pointing in the same direction. If I will consider region 3, because of positive E1 will be in outward direction, because of negative E2 will be in inward direction, and magnitude of this will be sigma upon 2 epsilon naught r cap. If you will consider direction also. Now, which sign will come with E1, which sign will come with E2 in a specific region, that we will consider. Now this is region first. E1 will be given as minus sigma upon 2 epsilon naught r cap, because E1 is in this direction and r cap is a unit vector that is from left to right. And what will be E2? E2 will be equal to E2, this side you are going to consider E2. E2 will be equal to sigma upon 2 epsilon naught r cap. And when you will consider the total sum of these two, then this will come out to be 0, because surface charge densities are going to be same. In the same way, you can try for this. In this case, both will be added in second part. When you are going to consider their addition, it will be sigma upon 2 epsilon naught r cap plus sigma upon 2 epsilon naught r cap. So resultant will be sigma upon epsilon naught r cap. And what will be direction? Direction will be from left towards right. In region 3, one is in this direction, one is in this direction. So what will happen? They will cancel each other because they will have equal magnitude but direction will be opposite. So they will cancel each other. Gauss's theorem is very important and its applications are more important because one or other it is asked most of the time in exam. This is 3 mark, again very favorite question of CBSE. Field due to uniformly charged thin spherical shell. So we have considered a spherical shell with radius r, and it is going to have a positive charge over it. We want to find out, because of this positive charge, what is the electric field at this point. This is our point of observation. So first step to find this was to consider a Gaussian surface. So we will consider a Gaussian surface that is in the form of a concentric sphere. Concentric sphere means the center of this sphere and center of this sphere is going to be same. This sphere is with radius r, capital R, and our Gaussian surface is with radius small r. Second step that we have considered last time to find electric field intensity was to consider the relation between E and ds. This is area element. On this, electric field intensity will be in outward direction at all these points. And if you will draw a normal, that will also be in outward direction. So angle between E and ds will come out to be 0. Third step was to solve this term, surface integral of electric field intensity for surface S, for closed surface. So E for a particular area element is going to be constant, so it can come outside the integration sign. And when you will consider the integration of this term, this will give the whole area of this Gaussian surface. So area of this sphere will come out to be 4 pi r square. Fourth step was to equate E into 4 pi r square with Q by epsilon naught. So here we have equated. From here E will be Q upon 4 pi r square epsilon naught. And if we will consider vector notation, then E will be equal to Q upon 4 pi r square epsilon naught. Now we will consider second case, because this question is asked, find electric field intensity due to uniformly charged thin spherical shell outside the shell, on the shell and inside the shell. So we will have our 3 points of consideration. First we have considered point P is outside the shell, and when second point I will consider point P is on spherical shell. On spherical shell means now Gaussian surface is just covering this sphere that we have already considered. In that case this will not be Gaussian surface, and rest of the things will remain same, only with one difference. Now area of Gaussian surface will not be 4 pi r square, small r square. It will become 4 pi capital R square. So rest of the things will remain the same. And we know surface charge density. Surface charge density is equal to charge upon area. So Q upon 4 pi r square I can replace with surface charge density. This replacement will be possible here only. It is not possible here, because surface charge density sigma is related to this sphere, not with this sphere. So sigma upon epsilon naught will be equal to electric field is possible only when we are writing or considering point P is on spherical shell. This is the maximum value of electric field intensity due to this thin spherical shell. Outside this is coming, on the shell this is coming, and R is greater than this R. So naturally this will be less, this will be more. Now third point, when the point P is inside the spherical shell. When it is inside, then what will happen? You will consider this surface to be Gaussian surface. Now net charge enclosed by it, what is this? Net charge enclosed by it is equal to 0. So when you will equate E 4 pi r square with Q by epsilon naught, electric field inside the spherical shell, what will be its value? It will come out to be 0. Now very important diagram related to this you try to understand. This is representing our original sphere. This is center. Along this axis we are going to consider distance or distance from the center of the sphere. This side we are going to consider value of electric field. See, when I will consider inside the shell, electric field was 0. So here this is value of electric field 0 inside the shell. When you will come on the surface of shell, R will be equal to capital R. Inside the shell, small r will be less than capital R. And when R is equal to capital R, we had maximum value of electric field intensity, that was sigma upon epsilon naught. Try to do practice of this diagram very carefully. You will not join this with this, because in this part electric field intensity is 0. On the surface it will have maximum value sigma upon epsilon naught, and outside it is going to have inverse relation with the square of distance. So outside the shell it will fall like this, inside it will be 0, and on the surface it will have maximum value sigma by epsilon naught. So prepare these topics very well.